today's video, we are going to cover section 1.5, division of segments and angles, proof problems. Let's look at a few sample problems. So we have problem 1. The tick marks indicate that line segment RS is congruent to line segment ST. Is S the midpoint of line segment RT? So for a point to be a midpoint, it has to be collinear with the other points. Therefore, S is not the midpoint of the segment. Problem 2. If ray BD bisects angle ABC, does ray DB bisect angle ADC? Now, just because this figure looks like a square and it looks like the ray will bisect angle ADC, if it is not told that the ray bisects the angle, we cannot assume that it is a bisector. So no, we would need more information. And problem 3, if B and C trisect line segment AD, do ray EB and ray EC trisect angle AED? Again, just because the points bisect the line segment doesn't mean that the rays will bisect the angle. So no, the rays will not bisect angle AED. Let's look at a couple proofs. So problem 4, given ray PS bisects angle RPO, we want to prove that angle RPS is congruent to angle OPS. So again, when I'm solving proofs, I like to mark my diagram with the information that I'm given. As your proofs get longer, it will be helpful and more beneficial to mark the diagrams as you go. So ray PS bisects RPO. Well, I know that an angle bisector divides the angle into two congruent angles. So I would know that angle RPS is congruent to angle SPO. That's my proof right there. So my first statement would be my given. So ray PS bisects angle RPO. Again, that's given. Then I have angle RPS is congruent to angle OPS. Why is this? Well, it's an angle bisector. So remember the definition of the angle bisector in the conditional form. If a ray, because the ray is bisecting the angle, so if a ray bisects an angle, it splits the angle into two congruent angles. Now notice that I said split. My reason here says divide. Just because your proof isn't the same exact reasoning as my proof, as long as it makes sense, it is completely acceptable. It doesn't have to be the exact wording every single time. You can use different words that have the same meaning. Split and divide have the same meaning. You can use those interchangeably. So don't get caught up in the nitty-gritty needing to make sure that I match every single word perfectly. You just need to make sure your logical flow is correct. Problem 5. Given line CM bisects line segment AB, now when we cover Unit 3 triangles, we'll call line segment CM a median of the triangle because it's a line segment that comes from the vertex and it divides the line segment into two congruent parts. We want to conclude that line segment AM is congruent to line segment MB. So again, my key word here is bisect. So I know if I have a bisector, it splits my segment into two congruent parts. So AM would be congruent to MB. So that's my conclusion, so I can create this proof. So my first statement would be my given, which is line CM bisects line segment AB. Again, that's given. Now I have my conclusion, which was line segment AM is congruent to line segment MB. And again, my definition of bisect, this is a line, so I need to make sure I say line in my conditional statement. So if a line bisects a line segment, then it splits the segment into two congruent segments. Problem 6, we're given line segment DH is congruent to line segment HF. I want to prove that H is the midpoint of line segment DF. So I know that DH is congruent to HF. Now I want to show that H, that point in the middle, is the midpoint. Well, I know from my definition of midpoint that if a point divides a segment into two congruent parts, then it is the midpoint. Notice from my diagram, I have this, so I can create my proof. My first statement, again, is my given, so line segment DH is congruent to line segment HF. Again, that's given. Then I have H is the midpoint of line segment DF. Again, reasoning for that is if a point splits a segment into two congruent segments, then it is the midpoint of the segment. In this lesson, we learned how to solve proofs that involve the division of segments and angles. Remember to make sure that you memorize the definitions from section 1.5, which were segment bisector, midpoint, segment trisector, angle bisector, and angle trisector. That's a wrap on this video. We'll see you in the next one.